All right, good morning to everyone. Yeah, hopefully everybody slept well. I'm also waking up, so I still have my morning voice. I hope you guys also have your own morning voice on. So let's please share the live with those that need to be here, especially those that we know familiarly are always here. All right. And I was going to actually ask that one of you, if one of you hasn't done so already, if one of you could actually start a group, a WhatsApp group for grade 9 alone and for grade 10 alone. If those WhatsApp groups have already been started, then that's good. And then I'd like the person who's actually the admin for that WhatsApp group to contact me on the side so that I can know what's happening in that WhatsApp group. But also furthermore, so that at some point when the WhatsApp group has a reasonable amount of people in it, I can be able to actually be invited to that WhatsApp group and become part of it. The grade 11s have already done that. I was actually so shocked yesterday when I actually gave my number over to one of the learners in grade 11 that have been attending these live sessions, and I actually realized they actually have over 100 members in their WhatsApp group of the grade 11 learners that join in our sessions. So now in that WhatsApp group, whenever they need like specific assistance with something, then I can actually send appropriate messages. If, let's say, for instance, they are doing the homework and maybe there's specific explanations that they need, then I can actually like reach out and assist them. What I also love is that they've actually developed then a community where they can actually assist each other with other things, not only just mathematics, but if they are doing other subjects like life science or geography or physical science, and they have a group together, then they can actually reach out and assist each other. So like I said, if one of you can do that, start the group on your own. There was one person in that group of grade 11s when I did a live session that took the initiative to start the group, and then she facilitated getting the numbers from everybody else that consistently joins in the sessions. And like I was so shocked yesterday when I saw like it's over 100 and so members in that group. I was like, what? Wow. So if you guys do that, just do that. I think when we have a sizable number of people in that group, then I will join in and assist. But let's make sure that these groups are not the same. If it's grade 9 alone, let it be grade 9 alone. Grade 10 alone, let it be grade 10 alone. I don't want mixing of individuals in that group, all right? Because we will be branching off at some point. Grade 9, I'll start having sessions with you alone because the content will differ from grade 10. But seeing as though it's still the same for now, seeing as though the syllabus is still the same for now, that's why I'm actually combining the sessions for grade 9 and grade 10 together so that we can cover the similar syllabus simultaneously. It also affords me just doing one session instead of doing two different sessions. Okay, so like I said, yeah, someone needs to volunteer amongst you to actually start the group. I am not going to start the group myself. Someone needs to volunteer to do that, and then that person needs to be obviously a person of integrity and obviously like who will be willing to start it. And then like I said, you send that your numbers to that particular person, and then that group can be started by that person. And then when the numbers are like, there's a sizable number of people in that group, and that person who's the admin should then send me a message on TikTok and just ask me to send their number. I also want to see evidence, at least, that there's a group. There is a group of people. With the grade 11s, I allowed them to first establish the group. They would report and say, now we have 50 members, now we have 80 members. And I was like, okay, let's see how we can build it. And then the minute they had like over 100, I was like, Makoma, you can take my number, invite me into the group so that I can start assisting you guys specifically. Also, if there's other material I would like to send specifically, then I can actually send that material in that WhatsApp group. It makes it a bit easier. because the live session sometimes maybe I may not be able to send or even maybe explain certain things more specifically. I can send a voice note and explain something maybe that maybe you guys don't understand. I can send an immediate video and send an explanation of that. So there's many various things I can do if we have that. Okay. So Usnokuhle, I think Ria is suggesting that Snokuhle starts the grade 10 and then Ria is volunteering herself to start the grade 9. So is that in order? Can you guys take that role and responsibility and then we can take it from there? Okay. So guys, today we'll be doing grade 9 and grade 10. Like I said, we are still moving with the two grades together. Okay. Alright, so Ria is obviously on point. Ria is going to be doing the grade 9 group. Then Snokuhle, you are in, I guess Snokuhle is in grade 10, so grade 10 will be started by Snokuhle. Okay, epic. Alright, so we have our two admin people. Alright, good stuff. Okay, epic. All right, so I think let's get on with today's session then. Let's get on with today's session. So yesterday, guys, we actually started with how to write. We started how to write decimals into fractions, right? Now, the thing is, the question in the exam when it comes to how to write a decimal fraction into a common fraction can be asked differently. They could maybe say, show that 0.31 is a rational number. Now, if we want to show that 0.31 is a rational number, then we would have to actually convert 0.31 into a fraction so that people can see that 0.31 can be written as a fraction where the numerator and the denominator are integers. So basically the question can be phrased differently, all right? That's just to accommodate people that are wondering, in this question, what should I do? So we had looked yesterday at how to write a decimal fraction into a common fraction, all right? And then what I'm saying is that you can be asked the question a bit differently with different phrasing. They could ask you to show that a particular decimal is a rational number. But to prove that a decimal is a rational number, what do we need to do? We need to actually convert that decimal fraction into a proper a common fraction, okay? Using the different methods, okay? So yesterday I left you with some homework. And I loved the fact that, like, some of you really did do the homework, and I could see that because you sent me messages privately to let me know that you had done it, okay? Just for those who are joining in for the first time, you may be catching the lesson now, and you may have not caught the previous lessons. What I do want to encourage you to do is you can go to my YouTube channel. On the screen, what you can see is the actual page of the YouTube channel. It's called Maths is a Game, All right. So it's at Maths is a Game 5 to 7. All right. That 5 to 7 indicates the levels that we are aspiring to achieve. Between level 5 to 7, that's our pass range. We only are going to accept a pass between level 5 and level 7, but what we are aiming for is a level 7, obviously, right? But our acceptable pass for people that are in this particular live session is level 5 to level 7. We do not accept any other pass. Anything less than level 5 is a fail for us, okay? So please go to the YouTube page, Maths is a Game, and subscribe to it. All the videos of the lessons that I've done so far have already been uploaded on that YouTube channel. That's including all other grades, grade 8, grade 11 as well. So you go on there, and what I've covered so far is already uploaded on the YouTube page. So you can rewatch some of the sessions that we've done, all right? And most of them start with an introduction like this, where I'm speaking a lot. So what you need to do is just fast forward a little bit and go to the place where I actually start the actual session, all right? I've not edited anything in the videos. I upload them as raw as they are, and then I allow you guys to navigate those videos, because I don't want to, I guess I don't really have time to edit. And I know some creators, they edit videos and all of that, but I actually really love uploading raw videos. That might not be popular, but that's just the uniqueness that I present when it comes to actually doing videos, live videos on my YouTube channel, okay? Raw videos, unedited, it's the way it is. Okay guys, so now we are going to start the session for grade 9 and 10. So if you are coming in, you're wondering what grade are we doing? We're doing grade 9 and 10. And we will do the corrections of the work that I sent you yesterday first. Then after that, we will actually continue with the rest of the topic that we have for rational numbers. Smart Study is asking, when are you starting with algebra? I'll only start with algebra after I'm done with the introduction session, which is basically covering numbers, rational numbers, and so forth. So it will most likely be in the middle of next week. So for now, I am doing the real number system, rational numbers and irrational numbers, how to convert decimals to fractions. Now we are going to be looking at the position of irrational numbers on a number line, and basically between which two integers does a particular irrational number lie, without using a calculator. So we'll be looking at that. We'll be looking at relationships between numbers, which is important as well, all right? And then only after we are complete or done with that, then we'll continue to do algebra. So your algebraic expressions, we'll do that for grade 10, because that's where we branch off with grade 10. But as for grade 9, we will branch off in a different direction. And the minute we branch off, that's when we are going to have different independent lessons for grade 9 alone and different independent lessons for grade 10 alone. So that's why then you guys starting the WhatsApp groups will be important, because then I can also announce certain things specifically to the groups as to when I'm having the sessions and so forth, okay? Please be open as well to your parents to let them know that there's something like this. Like if your parents don't already know, please let them know. Very important to do so. I know some parents are actually giving over their phones to their kids to just ensure that they are able to join these live sessions so that they can have the maths. Thank you so much, Smart Study, for both the TikTok and the rose. I really appreciate the gifts. Okay, let's jump into the lesson now. Okay, so yesterday we left each other off in this place. Okay. we left each other here. I had given you this homework that says write the following decimals as common fractions. Okay, and I had given you these 5 problems, and I said please go ahead and do these problems. And for instance, someone like let's see, I just wanna Snokuhle did these problems, and I think she did them spot on, 100% correct. She did send me her pictures of the work that she had done, and I was quite happy and proud of the way that she approached the problems. So I want to continue to encourage that, so especially now with the WhatsApp groups, it will probably be a bit more easy as well to send work that someone might have done on the side, so that I can be able to mark the work and give you feedback as you need. So here we are. How do we convert 0.41? So first and foremost, 0.41 we know is a terminating decimal, okay, because 41 it stops. So how do we convert that into a fraction? It's a simple 0.41, okay. We need to move the decimal so that we get a rational number. So we move the decimal, we move it to the left, to the right, how many times? 1, 2. Now we have the number 41, which we can write as our numerator value. Over what? Over, how many times did we move? 2 times to the right. So that means how many zeros? 1, 2. Then we place the 100 in the denominator. Now we need to check, can we simplify 41 over 100? So we take our scientific calculator, we punch in 41 over 100, and then we say equal. And then our calculator basically does not give us any further simplified fraction. So that means to convert 0.41 to a fraction, it's simply 41 over 100. This is how we deal with terminating decimals and converting them into fractions. This is how we show that this decimal fraction is a rational number, because a rational number is a number whereby the numerator and the denominator are both what? Integers, and where the denominator can never be what? 0. Okay, so that's number 1, done and dusted. Let's move on to number 2. 0.41. What does the dot on top of the 4 and the 1 stand for? It stands for the fact that 4 and 1 repeat. This means this is a recurring decimal, another type of rational number. So we need to convert this into a fraction. Okay, definitely very good here for life. So let's go. First and foremost, we write 0.41 with a dot dot, which means this is 0.41. This is grade 9 and 10. 41, 41, 41, and then we write dot dot dot, okay, to just indicate that basically that 41 repeats itself indefinitely or infinitely. Then step number 2, we let x be equal to this 0.41, 41, 41, 41, dot dot dot, and we write that as our second equation. Now you'll remember that we need to set up a second equation. This second equation, when we set it up, it needs to be in such a way that the decimals that we have for both equations on the right hand side after the comma need to be the same. I repeat, when we set up our 2 equations, the decimals on the right of the comma need to be the same, right? So what we do is we times the x by 10, and then we check what would be the new number on the right. That means we move the comma once to the right. So that means our number would be 4, 1, 4, 1, 4, 1, 4, 1, 4, 1 indefinitely. But let's look at the placeholder, 0 and 4 before the comma. 4 and 1, is this the same? No. 1 and 4, is this the same? No. 4 and 1, is this the same? No. So the numbers after the comma for both of these equations are not the same. So that means we need to set up another equation. How do we set it up? We are going to multiply the left-hand side this time of the original equation by 100. If we multiply by 100 in the left for the original equation, that means what happens to the movement of the comma? It means we move it 2 times to the right. Okay, so it's 1, 2. So that means our number will be 41, 41, 41, 41, 41, 41. Okay, so now we have the first original equation, the second equation, and the third equation. Now, we can clearly stop at this stage. We don't have to continue and write 1000x. We could do that, but we can clearly stop. Why? Because we can see that equation 1, the original equation, and equation 2 now satisfy the condition of there being similar decimals on the right. So I'm sure you can see this. 4, 1, 4, 1. Here as well. 4, 1, 4, 1. After the comma, we have 4, 1, 4, 1 for equation 3. After the comma, for the original equation, we have 4, 1, 4, 1. So that means now on the right-hand side of the comma, we have similar or the same numbers. When we have that for two equations, we can then take the two equations and solve for x. So how do we do that? We are going to take equation 3 and subtract equation 1. Equation 3, remember, is this one. Okay, we forgot the equal sign. That is 100x is equal to 41, 41, 41, 41, dot, dot, dot. That's equation 3. Then equation 1 is x is equal to 0, 41, 41, 41, dot, dot, dot. All right. So we give the instruction, equation 3 minus equation 1. Then what do? We subtract as we had instructed. 100x minus x gives us 99x. Then 41 before the comma, 41 and 0 are there before the comma. What's 41 minus 0? It's 41. Then after the comma, 4, 1, 4, 1. If I subtract 4 and 4, I get 0. 1 and 1, I get 0. 4 and 4, 0. 1 and 1, 0. 4 and 4, 0. 1 and 1, 0. That will happen infinitely. I will forever have comma 0, 0, 0, 0. So that leaves me with a integer 41. So now 99x is equal to 41. What I then do, I divide both sides by the coefficient of x, which is 99. And then I get a final answer, which is x is equal to 41 over 99. Then you take your calculator, you punch this in, 41 divided by 99, and check, do I get a simpler answer than this? Or is this answer the final answer? Or can I simplify it further? Can we confirm, guys? Is this the answer? Or can it be simplified further when we punch it into the calculator? 41 divided by 99, do we still get 41 over 99? Or is there a number that is simpler than this? Thank you, Snokuhle. So it is the answer. Then we leave that as that. So what then we are saying is that 0.41 with the 41 repeated or recurring can be written as 41 over 99. You could even confirm this. Take this 41 over 99, punch it into your calculator, say equal, and then press ST. This should give you back this number 0.41414141 repeated infinitely. You can check your answer, guys. You don't have to write this and then proceed and think that, oh, it's right. You can check and verify if this answer is actually correct by putting 41 or divided by 99 into your calculator and checking if it does it still give you back the repeated 414141 by pressing this into your calculator, writing equal, pressing equal, and then pressing ST just to confirm and verify. This is for those people, for instance, that sent me their work and they saw that they could not get the right answer. All right, check your answer so that you can move on to the next question having checked the answer. So hopefully that's clear. So this setting up of equations is important. All right, setting up two equations which you can subtract and which can ultimately help you to get the rational number by which 0.41, the recurring decimal, 414141, is actually expressed as. So this is 41 over 99. Let's move on to the next question that I had for you. So the next question was 0.4, but who repeats? Only the 1, not the 4. Okay, so let's look at that one. How do we answer the question? 0.4, 1. So it's only the 1 that repeats. So we can write that as 0.4, 1, 1. Okay, so hopefully that's clear. So then we'll say let x be equal to 0.4, 1. Equation 1. Then to set up equation 2, what do we do to the left? We multiply by 10. But then, which means we move the comma how many times? Once to the right. So the new number will be 4, 1. Equation 2. But if you look at these two equations, do you have similar numbers after the comma? For the two equations, do we have similar numbers? There's 4 here for the first number after the comma. There's 1 here, the first number after the comma. So we don't have similar numbers, which means these two equations, we cannot use them. So that means we need to move on and multiply by 100. So if we multiply for the original equation by 100 and the left, it means we move the comma how many times to the right? Twice. 1, 2. So what do we get? 41, 1. Equation 3. Okay, so hopefully that makes sense. Buhlendipi, the funny thing is I had a student in my school that actually did great. The student was made to do maths lit in grade 10. All right, and then this is in my school. The student was made to do maths lit in my school in grade 10 because of his marks in grade 9. Then during his grade 9 term 1, he discovered that maths lit was too easy for him. So what he did is he went to his parent, he told him this, and then his parent came to me and he was like, I want my student to change from maths lit to pure maths because he's killing the maths lit. He's doing too well and it seems too easy for him. So then he changed. I called his parent, we met with the principal, we sat in the office, we discussed it. The learner changed after term 1. After term 1, he changed from maths lit to pure maths. That boy has been killing pure maths ever since. He's been doing so well in pure maths, grade 10. He killed the maths, level 7, grade 11. And then now we're going to grade 12 next year. And like, he's an amazing student. I was like, wow. So that's just a story for you. Anyways, so we multiply the left-hand side by 100. Okay, and then that means we move the comma how many times to the right? For the original equation, twice. So we have 41, 1. Now look at equation 1 and equation 2. After the comma, the numbers are not the same. Look at equation 1 and equation 3. After the comma, there's 4. After the comma, there's 1. 1 and 3 don't have similar numbers after the comma. So we can't take equation 1 and 3. But look at equation 2 and equation 3. What do you notice? After the comma, we have 1. After the comma, we have 1. So these have the same numbers after the comma. So that means we can take equation 2 and 3. We don't even have to set up a fourth equation here because we can immediately see that, oh, we do have two equations where after the comma, the numbers are the same. So we are going to say equation 3 minus equation 2 because we always take the big number equation minus the small number equation. So let's go equation 3 minus equation 2, set it up. 100x is equal to 41, 1. Equation 3, then equation 2, 10x is equal to 4, 1. Equation 2. We subtract those two equations. So what's 100x minus 10x? 90x. Then 41 minus 4. 41 minus 4 will give you 37. Then after the comma, the 1, 1, 1s, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0. That's what we want. We want to have a whole number without having to find that there's a decimal. 1 minus 1 is 0. So the 0 basically leaves me with the integer 37. Okay. So then we go ahead and we divide both sides by the coefficient of x, which is 90. Then we get x is equal to now 37 over 90. If you put this in your calculator, 37 divided by 90 or 37 over 90, can we simplify this any further? Or is this basically the answer? Thank you guys for the follow. Those who are joining in for the first time, thank you for the follow. You are welcome to the live. We're doing grade 9 and grade 10 maths, term 1. We are starting from the bottom. Now we are here. 37 over 90. Is this the simplest? Yes, Nokute, thank you so much. 37 over 90. Right? Then you can take this, take this, say 37 divided by 90, press SD and check, do I get this 0.41 with the 1 repeating? You should. Okay, that confirms that this is the rational number that represents 0.41 where the 1 is repeating. Okay. Guys, I'm sure you guys are getting the mojo. We have 2 more examples that we need to do not 2 more examples, but 2 more homework problems that we need to cover, and then we will start with today's session. 0,056, where the 56 is repeating. Okay, so 0,056. All right, and then we'll have 0,056, where it's the 6 that's repeating. So let's start with this one. 0,056, when the 5 and the 6 are repeating. So first things first, let's write out the number. This is 0,0565656. So the 56 is repeating. So that's our number basically, and it's ongoing, the 56. Then what we do is we let x be equal to 0,0565656. That's equation 1. Then if we multiply the left by 10, all right, okay, and sometimes now we don't have to actually physically write the equations, but if we can say an equation does not qualify, then we don't have to write it. But I think just for starters, let's do it. 10x is equal to, that means we move the comma how many times? Once. That means we have 0,5656565. That would be equation 2. After the comma, the numbers are the same. After the comma, we have 0 immediately. After the comma, we have 5 immediately. So the numbers after the comma are not the same. So these 2 equations are not enough. So I'm going to have to move on and check 100x. That means we move the comma how many times to the right for the original equation? Twice. So that means 1, 2. That means I have 5, 6, 5, 6, 5, 6, 5, 6, 5. Equation 3. Let's check. After this comma, we have 0. After this comma, we have 5. After this comma, we have 6. So far, from all the 3 equations, there are no 2 equations I can set up. So I move on. Let's check 1000x. Okay. And let's look at the setup of 1000x. We're moving the comma how many times to the right? 1, 2, 3. So that means I have 56, 5, 6, 5, 6, 5, 6, ... equation 4. Now, is there an equation so far that has the same numbers after the comma, guys? After the comma, 0. After the comma, 5, 6. After the comma, 6, 5. After the comma, 5, 6. So that means we have equation 4 and equation 2. We could utilize those 2 equations. So we're going to say equation 4, big equation, minus equation 2. Grade 10 and 9. So if you're in grade 10 and 9, you are in the right place. All right. Okay, so equation 4 minus equation 2. So equation 4 is 1000x is equal to 56,565656. Then equation 2 was 10x is equal to, equation 2 was 0,565656, because these two equations, we are taking them down because they have the similar numbers after the comma. All right, equation 4 and equation 2. Yes. Okay, so guys, we are basically choosing the two equations that will allow us to be able to get a rational number, numerator and denominator being integers. So that's why we do the setup of equations. We do it until we can see that, oh, there's two equations that have the same number after the comma, the same numbers after the comma. So equation 1 originally was 05656. Equation 2 is 56. Equation 3 is 65. Equation 4 is 56. So equation 4 and equation 2 are the two equations I can choose because they both have 56, the same thing after the comma, and it repeats. So I take equation 4 and subtract equation 2 from it. So that means 1000x, which is equation 4, is equal to 56,565656. That's my equation 4. And then my equation 2 as well. 10x is equal to 0, look after the comma, 565656. So those are the two equations I need. I subtract them. So let's do the subtraction. What's 1000x minus 10? 1000x minus 10. Hopefully you guys can tell me what 1000 minus 10 is, so that I can write down your answer. What's 1000x minus 10x? Okay, I could just write the answer, but I just want to check. I want to check people if they are awake. Thank you, Sia, for life. It's 990, x. Then on the other side, don't forget the x, 56 minus 0. Before the comma, we have 56 and 0. So it's 56 minus 0, which is 56. Then the 5 minus 5, 0, 6 minus 6, 0, 5 minus 5, 0, 6 minus 6, 0, 5 minus 5, 0, 6 minus 6, 0. So basically there's nothing after the 56. So that means I have an integer. Then I solve for x by dividing both sides by the coefficient of x is 990. So what I do on the left, I do where? On the right. Then my final answer is, okay, this is not my final answer, but so far, I get 556 over 990. And then check with your calculator. Take 56 divided by 990. Press equal in your Casio scientific calculator. And then check what do you get as the answer. Okay, Snokuhle is on the money. Yeah, Snokuhle was the one that basically did 100% when she did her homework. So proud of her. And then she did send me the work on the TikTok DM, and I could see that, like, you're spot on stuff. Okay, 28 over 495, and that is our simplified fraction. You can take this, put it in your calculator, then press equal, then press SD. You will see that it actually does give you back this 0, 0, repetition of 5, 6, 5, 6, 5, 6. I think at the end, at some point, it will round up, it will round off the last digit on your calculator. Why? Because your calculator basically rounds off the answer, the number at the end. All right, either it's the 7 or the 6 at the end. Why? Because your calculator does not have all the space that could accommodate all the numbers, because it's infinite in number. So Tasha 182, definitely what happens is that they round off the 6, right? So it becomes 7 at the end, okay? Why? Because your calculator has limited space. It can it rounds off your last digit. But in all reality, if we had a calculator that was infinite in nature, extending forever and ever, you would see the 5, 6 running on and on and on indefinitely, okay? So don't be discouraged. It just means the calculator rounds off. It does that normally. It is a calculator after all. It's a programmed device. Okay. Then the last question that you guys had to do for homework was 0,056, where the 6 is the one that repeats. Okay. So let's quickly do that and then move on to what we need to cover for today. Okay, let me just move to another clear page because that one is clearly going to be presenting problems. 0,056 where the 6 repeats. So first and foremost, let us spell out what that number is. It's 0,05. Who's repeating the 6? 6, 6, 6, 6, 6. Okay. All right, I'm sorry to be writing that number. 666. Some people are having eerie moments with the 6666. Anyways, let x be equal to 0,056666. Set that up as our equation 1 because it's the 6 only this time round that is repeating. The 5 is stationed, the 0 is stationed, but the 6 is repeating. Then let's 10x multiply it. What happens? We move the comma once, so that means our number is 0,56666. Equation 2. But those two equations don't have similar numbers after the comma. After the comma, we have 0. After this comma, we have 5. So it's not going to help us. Move on. 100x. Let's check 100x. That means we move the comma how many times? For the original equation, 2 times. 1, 2. All right? So that means our answer. Okay. We are converting decimals, Tasha. We are converting decimal fractions into rational numbers, in other words, common fractions. We are converting that. That's what we are doing here. So this is homework that was given in a previous live session, and we are going through that, the homework and how to answer it, right? So if you are joining in for the first time, you are more than welcome to go and watch the previous live session that we did. I have a YouTube page. It's called Maths is a Game. You can go and subscribe on that. Watch the previous video that I did on the grade 9 and grade 10, how to convert decimals to fractions, and then you can basically check out how we do that, and then all the other live sessions I've done this past week so far, all right, for grade 9 and grade 10, and for grade 9 and grade 10 respectively. You can go on there. The YouTube channel as well, if let's say for instance you can find it by typing in Maths is a Game, you can always go to my bio, click on the icon, the YouTube icon, it will send you directly to the YouTube page. I hold and I host live sessions for maths daily, so that's for grade 8, 9, 10, and 11 at different times. Okay, sorry, let's go on. So 100x means we move the decimal for the original equation how many times? Twice. So that means we move the decimal 1, 2. So that means we're going to have 56, 6666666. That's equation 3. So far, do we have two equations that have the same numbers on the left after the comma? On the right after the comma? This is 0 after the comma. This is 5 after the comma. This is 6 after the comma. So far, we don't. 1,000x. So if you multiply by 1,000x, that means we move the comma how many times to the right? 3 times to the right. 1, 2, 3. 100 was 1, 2. Oh, sorry guys, there was an error here. This here was supposed to be moving the comma. 100 means I move the comma how many times? Twice. So that's 1, 2. So I should have written 5,6666666. So I made a mistake there, guys. That was a big mistake. 100x, like I said, I move the comma twice, so it's 1, 2. So my number after the comma, this side should be 5,666, not 56. 5,666, okay? But so far, you can see 0 after the comma, 5 after the comma, 6 after the comma. Don't have same numbers on the right so far. So I go on to 1,000x. Go to the original. X is equal to, move the comma how many times? 3 times. 1, 2, 3. So my number will be 56, comma. So let's write it 56, comma 66666 dot equation 4. Okay. I'm glad I picked up on my error on my own, because if I didn't pick up on the error on my own, it would have been a big disaster. Okay. So when you are aware of what you are doing, you can pick up on your errors. But it's also advisable as well that when you are done with the problem, you go back to your problem and just check if you did everything accurately, so that before you move on and answer the next problem, you have checked on your personal errors. Okay. Now, equation 3 and equation 4 obviously exhibit numbers that are the same after the comma. Comma 666, comma 666. That's equation 3 and equation 4. Grade 9 and 10. Butterfly girl. Grade 9 and 10. So I can take equation 4 and subtract equation 3 from it. That's what I can do. Equation 4 is 1000x, which is equal to 56,6666. Equation 4. Equation 3, on the other hand, is 100x, which is equal to 5,66666. Dot, dot, dot. Now I can subtract the two. It's grade 9 and 10. 1000x minus 100. Okay, I'll wait for someone to tell me. And then 56 minus 5. Because the 6's here will cancel out. 6 minus 6, 0, 6 minus 6, 0, and so it goes. CF for life and Tasha, thank you so much. It's 900x. Then, what's 56 minus 5? 56 minus 5. Do you see, guys, I'm writing the numbers with each placeholder underneath the relevant placeholder. The 6 is underneath the 5. The 5 is, there's nothing underneath the 5. The sixes, they cancel each other. So we have 51, guys. Very good. 900x is equal to 51. Then, what do we do after that? We divide both sides by 900. Then we get an answer of x is equal to 51 over 900. This is our rational number. This is our fraction. Does it end there, guys? Does it end there? Or can it be simplified? I just want to check. Okay, let's say, thank you so much, guys. So we have a nice answer of 17 over 300. Take your calculator, punch in 51 over 900, get the answer as 17 over 300. So we need to make sure that we have a final answer that is simplified. If we write the answer as unsimplified, we lose a mark. But if we write the answer as simplified, we get the entire mark. If this was not unsimplifiable, then we would leave it like this. We'd still get our full marks. But because it is simplifiable, our last mark will receive by writing the answer in simplified form. Then you can take the 17 over 300, put it into your calculator and check. Do you get 0,05? 66666666666? I think your calculator will round it up at the end with the last digit and write 7 at the end. Okay. Tasha, you are way ahead of your game. We are not even there. We are doing the syllabus for grade 8, 9, 10, different sessions, different times, and we are taking it slowly from term 1 each session. I want you guys to understand that if you want to eat an elephant, you're not gonna just take the elephant and shove it into your mouth. It's unshovable. So what you do is you need to take small segments. Today you eat the ears, tomorrow you eat the trunk, the next day you kind of chop off the head. You start dismantling different parts of the head and eating that. You braai it if you want, you cook it if you want, depending on your preference. So we take things one step at a time, and that's what I'm doing, all right? So please, there are many live creators that are actually teaching maths, and I think some of them are well established. Some of them have their YouTube channels and so forth. I know there's a person called Mlungisi Nkosi who's like a phenomenal teacher on YouTube. There's also Kevin Maths and Science. They are like phenomenal people, well established. They have videos for days of like all the content that you can think about in the world. So you guys can go onto their platforms and you can start covering the different topics that you want using their content, okay? But for me, I'm taking it slowly. So unfortunately, Trig is very far for now. The time will come though, okay? The time will come. The time will definitely come, all right? Okay, so let's look at what we are going to cover today. Today, we are actually going to look we are going to look at the position of irrational numbers on a number line. Okay, position of irrational numbers on a number line. And then specifically, we are going to look at questions such as this: between which two integers does the cube square root of 31 lie without using a calculator? Between which two integers, this is important, integers, does the square root of 31 lie? And we want to do that without using a calculator. All right. So, first and foremost, I think we all need to establish that the square root of 31, we can all agree that the square root of 31 is what we refer to as an irrational number. Why? Take this square root of 31, punch it into your calculator, and then press equal, and then after that press SD. Okay, I want you guys to tell me what you get from your calculator. I know we don't use a calculator when we do these things, but I just want to establish for you guys what the square root of 31, why are we saying the square root of 31 is a irrational number. Let's start there. We're going to answer the question, by the way, the one that says between which two integers does the square root of 31 lie, without using a calculator. We're not going to use a calculator. Okay, thank you so much. You are the lady. 5,567,764,363. Right? So this here is what we refer to as a irrational number. Why? Because the decimals are what? They are non-recurring and they are non-terminating. I think we've established this in so many lessons, that irrational numbers are numbers that cannot be written as a fraction where the numerator and the denominator are integers, okay, and where the denominator cannot be zero. But when we look at decimals, we know that irrational numbers have non-recurring. In other words, there's no repetition of a pattern of numbers after the comma. Someone will say, but sir, there's a repetition of 7 and 7. Yes, but that's limited. It's not a repetition that you can see as a pattern throughout the numbers after the comma. Someone will say, but there's a repetition of 6 and there's a 6 there. But it's not a consistent pattern of repetition of numbers, okay? So that's what we are talking about when we say non-recurring, meaning there's no repetition pattern throughout, and non-terminating. In other words, after this 3, there's no stop, guys. There's other numbers, but the pattern of numbers after the 3 are not the same. There's no pattern after the 3. It's like different numbers. If you were to see a bigger screen of a calculator and see other numbers that are there, you would see that there's no pattern at all, and there's no stopping. In other words, no repeating, no stopping. Non-recurring means no repetition of numbers, no repetition patterns, and no terminating, meaning no stop to basically the numbers. So that's why we say the square root of 31 is a irrational number. It does not behave. Okay. Now, we want to find between which two integers does the square root of 31 lie without using a calculator. Now listen to me. First and foremost, you write down the square root of 31. Then you do the following. You put this less than sign on both sides of the square root of 31. I need you guys now to find two perfect squares. Two perfect squares. I need from you guys to write for me two perfect square numbers. a perfect square number that is before 31, and a perfect square number that is after 31. So perfect squares, let's just review what perfect squares are. 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. 25 is a perfect square. 36 is a perfect square. In order. 49 is a perfect square. And maybe you guys are like wondering, what in the world is happening? How do you know that 1 is a perfect square? It's because it's formed by multiplying a certain number by itself. That's 1. 2 is formed by multiplying 2 by itself. That's 4. 9 is formed by multiplying 3 by itself. That's 9. 25 is formed by multiplying 5 by itself. But we missed a number. 4 times 4 gives me 16. So we missed 16 in the order. 1, 4, 9, 16, 25. 36 is formed by multiplying 6 by itself. 49 is formed by multiplying 7 by itself. So these numbers, we refer to them as perfect squares. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square, 36 is a perfect square, 49 is a perfect square. So think about it in this way. If we had 31, let's not put the square root. What perfect square could we write before 31? What is the perfect square that falls immediately before 31? Let's go back here. You can see there's 49, so that's not the perfect square that falls before 31. 36 is a perfect square that falls after 31 immediately. 25 is a perfect square that falls before 31 immediately. Does that make sense, guys? So the minute I put a square root of 31, we are back to that number, that irrational number. Now, we can take a square root for both of these perfect squares as well, just so that we can put them in the same level. What's the square root of 25, guys? It's 5, right? What's the square root of 36? It's 6, right? Therefore, we can make this conclusion that the square root of 31 actually lies between what? 5 and 6. And that's it, done and dusted. Okay. Hopefully we get this, we understand this. So all I'm asking you guys to do is to find the what? We want to find the two integers that the square root of 31 lies between. So in order to do that, we need to find the two perfect squares, one perfect square that is just immediately before 31, and one perfect square that is immediately after 31. We want the immediate ones, not the ones that are further along. For instance, we wouldn't write 49 here because 49 is further along as a perfect square after 31. So that's why we would write 25, we'd write 36, because these immediately follow each other. But then we put a square root so that it actually is conforming to the square root of 31. Then, what's the square root of 25? It's 5. What's the square root of 36? It is 6. Then we can make a conclusion, because we found the integer. The integers that the square root of 31 lies in between are 5 and 6. Square root of 31 is between the 5 and the 6. The 5 is before 31, the 6 is after the square root of 31. So therefore we say the square root of 31 lies between, and this is our conclusion, 5 and 6. Done. So this is the method that we need to apply to finding the answer without using our calculator. Yes, we leave it like that here for life, because remember, this is an irrational number, and an irrational number is fine if we express it in its root. Okay, all right. So hopefully then we guys are clear here. This is a grade 9 problem, but also a grade 10 problem. You can be asked this kind of question even in grade 9, as well as grade 10. If you were never taught this question in grade 9, it just means that you missed out on something fundamental when you were doing grade 9. Okay, so you can be asked a question like this even in grade. I've seen it in past papers, hence I'm actually like covering this with you guys as well as grade 9. Grade 10s, you guys need to know this like nobody's business, but this also applies to grade 9 learners as well. Okay, so that would be our solution. Okay, does anyone need clarity or further clarification on this, or are we good? Do we understand it? Are we good? Are we clear? All right, maybe let's do one more example. So that was the example 1. I just want to explain what this actually means. This here, this is like saying the square root of 31 is greater than the square root of 25, but it's less than the square root of 36. I repeat, this is like saying the square root of 31 is greater than the square root of 25. That makes sense, guys. Yeah, that the square root of 31 is greater than the square root of 25. But it's less than the square root of 36. Okay? So hopefully that makes sense. That's why we need to identify perfect squares. Immediate perfect square before 31, immediate perfect square after 31. And then we write those down, we put the square root, we get the answer. Perfect squares can be written as integers. That's what's beautiful about perfect squares. When they are under the square root, you can write and express them as integers. And that's why we say the square root of 31 lies between 5 and 6. Okay. Let's move on to something else. Let's move on to another example. Between which two integers does the square root of 7 lie between? All right. Maybe you can quickly do this one. All right, step by step, and then I'm sure you have a pen and a paper there. Quickly do this one. All right. Remember, we need to first we put in these symbols. Okay. Okay. Remember, and sorry. This is very important. I need to emphasize this. Between which two consecutive, and this is the word that I forgot, consecutive integers. Ooh, guys, sorry, I need to emphasize this. Consecutive. What does the word consecutive mean? It means one number following the other. We want to find two consecutive integers whereby square root of 31 lies. So do you see what I did here? 5 and 6, these are numbers that follow each other. 5 immediately is followed by 6. That's why consecutive integers is basically the adjective or the word that we need to take into consideration. These can't just be integers that are just, are ways apart. They need to be integers that are next to each other. So 2 is followed by 3. Those are consecutive integers. 5 is followed by 6. Those are consecutive integers. 9 is followed by 10. Those are consecutive integers. So you need to find consecutive integers, not just any integers. You need to find consecutive integers, one after the other. 5, the gap 1 is followed. 5 is followed by 6. All right. So if you're going to say to me it's 4 and 9, 4 is not followed by 9. Or at least, sorry. Remember, you need to actually make sure that when you write that number, remember we said 25 and 36, but then we put it under a square root. And then we got 5 and 6. Okay. And then CR for life, you are saying the square root of 7 lies to 4 and 9. Can't be. Thank you, let's say 2 and 3. Okay. So first and foremost, we find the perfect squares. What are the two perfect squares before square root of 7? Let's think about the perfect square. Remember, perfect square 1, 4, 9, 16, 25, 36, 49. What is a perfect square that's before 7? Okay. Think about it. Before 7. Immediately before 7. That would be 4. Immediately after 7. That would be 9. We can go back to our list of perfect squares. Remember, 4 and then followed by 9. So these are immediately after each other. But then immediately after that, we take the square root, because we have square root of 7, so we need to have square root of 4 and square root of 9. What's the square root of 4? It's 2. What's the square root of 9? It's 3. So 2 and 3. We say the square root of 7 lies between 2 and 3. Okay, makes sense, guys? So please take note, take a special note of that. Very, very important. Okay. And why do we say perfect squares? It's because we have a square root. That's why we deal with perfect squares. Okay, I want to throw a spanner in the works. So hopefully example 2 is understood. Let's look at example 3. If the question says between which two consecutive integers does the cube root of 27 lie? Okay, please take note. Between which two consecutive integers does the cube root of 27 lie? Liam, I have a session for grade 11 at 11 a.m. today, so I'm not doing grade 11 now. I'm going to do grade 11 later on at 11 a.m. Those who joined in the session yesterday, because we have a standard grade 11 session that's always held at 9 p.m. in the evening. So I asked the grade 11s last night that were joining in the session to join in the session at 11 a.m. today, so we can do the corrections of the work that they've done so far, and then we'll only do the actual session of what we needed to cover today at 9 p.m. as usual. Okay. So between which two consecutive integers does the cube root of 27 lie? So let's write down the cube root of 27 first and foremost. Take note that this time round we have the cube root. It's not the square root. So with that said, that means I am going to have to look for what this time? I'm going to have to look for perfect cubes, not perfect squares. I'm going to have to look for perfect cubes. And some of you are going to be like, what do you mean now, sir, by perfect cubes? So let's write down what the perfect cubes are. 1 is a perfect cubed. 8 is a perfect cubed. 27 is a perfect cube. All right. Sorry, let's write the cube root of 28. Sorry, not the cube root of 27. Okay, so we are wanting to find between which two integers does the cube root of 28 lie. The cube root. Between which two consecutive integers does the cube root of 28 lie. All right, I just rewrote the question. Please, people. Okay, between which two integers does the cube root of 28 lie? So we have to identify what the perfect cubes are. 1 is a perfect cube, 8 is a perfect cube, 27 is a perfect cube, 64 is a perfect cube. How do I know that? 1 times 1 times 1 3 times is equal to 1. 2 times 2 times 2 is equal to 8. 3 times 3 times 3 is equal to 27. 4 times 4 times 4 is equal to 64. And I'm sure you guys get the drill. 5 times 5 times 5 is 125. And so it goes. All right. So which two perfect cubes that follow each other can I write immediately before 28 and immediately after 28? So let's look at this. Immediately before 28, let's write down 28 without the cube. We know that there's a cube root, but immediately before 28, what do we have? Immediately before 28, we have 27. And then immediately after 28, we have 64. But remember, this was a cube root. And this cube root of 28 is obviously a irrational number. If you take this and put it into a calculator, you will get an irrational number, meaning a non-terminating and non-recurring decimal. Then now we can safely put the cube root for each perfect cube. But what is the cube root of 27? Obviously, it's 3. We retain the cube root of 28. What's the cube root of 64? Obviously, it is 4. Therefore, the cube root of 28 lies between 3 and 4. So hopefully you guys get this, and we are good, and we understand, and we are clear. Any questions? Hopefully there's no questions. Hopefully we are all in the same page, and all of us, we are really like, oh, okay, makes perfect sense. Wow, thank you so much. Didn't know this. The cube root of 28 lies between 3 and 4. So we need to always look at the type of irrational number we have. If it's a square root, then we need to look for perfect squares. If it is a cube root, then we need to look for perfect cubes. Okay. The name of this section is how do we find the position of rational numbers on a number line. Okay. This is a topic applicable for both grade 9 and grade 10. So this is still under rational and irrational numbers. Okay. So we did converting a decimal into a fraction. That was specifically looking at rational numbers. Now we are looking at a specific example where we are trying to find between which two consecutive integers does a particular number, which is irrational, lie, right? So we've looked at how many examples? First example, we wanted to find out between which two integers does the square root of 31 lie. We found those two numbers. It's 5 and 6. And there's a certain method that we followed. Then we asked ourselves, between which two integers does the square root of 7 lie? And we found those two integers. And then last but not least, between which two integers, consecutive integers, does the cube root of 28 lie? So since we are now dealing with a cube root, it means we need to find two perfect cubes, one before 28 and one after 28. Okay, and it has to be a perfect cube, not a square root. This not a perfect square this time round, because we are dealing with a cube root of 28. Then obviously we said the cube root of 27 is 3, and the cube root of 64 is 4. So therefore we conclude that the cube root of 28 lies between 3 and 4. And clearly 3 and 4 are consecutive. They follow each other. Right? The last thing I want to cover today is rounding off decimal numbers. Rounding off numbers. That's another important subtopic for grade 9 and grade 10. Rounding off numbers. Maybe some of you will be like, I say, rounding off numbers, that's easy. That's fine. I'm glad you're saying it's easy. Please let it continue to be easy. Rounding off numbers. So I'm going to teach this using examples. Let's look at your first example, example 1. Okay. Let's say we have, it says round off the following to the appropriate decimal. Okay. Remember, when we round off something, that's like taking a number and expressing it as a terminating decimal. Because wherever we decide to stop, if we say rounding off to 2 decimal places, it means we are terminating that number to the second decimal place. So that's like writing whatever number into a rational number as a decimal. So let's say we had 0.725. And the question says here, round off to 2 decimal places. Okay, so I'm sure some of you already know what the answer. If I say round off 0.725 to 2 decimal places, let's just check in the comment section if people actually know off by heart what 0.725 to the second decimal place can be expressed as. Let's wait. 0.725 to the second decimal place will be equal to, if I'm rounding off that number to 2 decimal places, 0.725 will be equal to know me, 72.5. Let's say not 72.5. Okay, we are rounding off, right? Rounding off numbers here. Okay, I think now that means I'm going to have to teach this, all right? Because no. Okay, let's go. So if we are rounding off numbers to an appropriate decimal place, okay, this is what we do. First, write down the number 0.725. Write down original number. Okay, so the original number here is 0.725. Then, what we do after that, Princess, you are spot on. We check. When we say 2 decimal places, what are we saying? This is 1 decimal place. This is 2 decimal place. So that means we are going to write a line. So this is just a method, guys. Okay, we are going to write a line after the second decimal place. The place where we have to round off, we write a line, a vertical line. Then we underline the number after the second decimal place, which is 5. Now this number speaks, this number. If the number underlined, and this is the important point, is 5 and more, it says to the number before it, let's go up by 1. Yes, I'm going to repeat again. We first write the original number, 0.725. Step 1. Step 2. Since the question is saying round off to 2 decimal places, that means we look at our number after the comma. This is 1 decimal place, 7. This is 2 decimal place, the second number. We write a vertical line, all right? And then that separates this third number. We underline the third number after the vertical line. This number, it speaks. What does it say? If the number underlined, okay, is 5 and more, it says to the number before it, let's go up by 1. Then it falls away. It's like a messenger. It comes to bring a message, then it leaves. You know how they say don't shoot the messenger, okay? So it comes to bring a message. If this number is 5 and more, it says to the previous number, let's go up by 1. So what does it mean then to go up by 1? It means our answer, rounded off to 2 decimal places, will be 0.7. If 5 is saying to the 2, let's go up by 1, going up by 1 for 2 means the answer will be 0.73. Then the 5 falls away. So our final answer is 0.73. We've just rounded off 0.725 to 2 decimal places. Okay. All right. I don't know if anyone has any questions. Okay. So this is important. If the number underlined is 5 and more, so if this number is 5 and more, meaning if this number is also 6, it still says let's go up by 1. If it was 7, it still says let's go up by 1. If it was 8, it still says let's go up by 1. If it's 9, it still says let's go up by 1. I'm going to look at another example. Let's look at another example. 0.724. This is grade 9 and 10. So whether you're in grade 9 or in grade 10, this is relevant for you. Yes. Let's listen before we jump to conclusions. All right. Look at this one, 0.724. Let's say we were also told to round off to 2 decimal places. Okay, 2 decimal places. Just wait, hold us in a sec. Just hang on tight, just need to hold on. Okay. All right, be with you now. So let's round this off to what? To 2 decimal places, 0.724. 2 decimal places. So first and foremost, what did I say? We write down the original, 0.724. Then since it says 2 decimal places, it means what? It means after the comma, we count 1 decimal place, 2 decimal place. Then we write a line at the cut off of the second decimal place. Then we underline 4. Okay. Now, here's another one for you. If the number underlined is 4 and less, then the number before it stays the same. If the number underlined is 4 and less, then the number before it stays the same. I repeat, if the number underlined is 4 and less, then the number before it stays the same. So that means the answer will be 0.7. What does the 4 say to the 2? It speaks and it says, 4 says to 2, you stay exactly as you are. So therefore the answer is 0.72. Then the 4, what does it do? Then the number falls away. It gives the message, falls away. All right. Now, this rounding off business kind of brings me to a place where I want to teach a lesson to kids that are growing up. In life, it's either in life you surround yourself with the kind of people that will improve you and progress you. Do you remember what I said? I said if the number that is underlined is what? Is 5 and more. What happens to the number before it? It actually goes up by 1. Then the number, what does it do? It falls away. So in life, you can surround yourself with people that can leave you improved. This 0.725, the 5 does what to the 2? It improves it. It makes it better. As long as the number that's underlined is 5 and more, it will always lead to an improvement by 1. Or in life, you can surround yourself with people that will leave you staying the same. I think we need to choose, right? But this depends on whether the number underlined is 4 and less. Then it says to the number before it, stay the same. Okay? At least it doesn't pull it down. It leaves you the same way that it basically found you. So therefore the answer is 0.72. Okay? Who here does not understand what rounding off means? Okay? All right. Hopefully we all understand. Okay. Let's take it up. 0.8573. Let's say they said this number we need to round off to 1 decimal place. Okay, round off to 1 decimal place. So once again, we first write down the number 0.8573. Then rounding off to 1 decimal place means our cutoff. We count 1 decimal place, we cut off here. Okay? Then we underline the number that will speak. Then we say, friend, speak to the 8. What do you say to the 8? So the friend speaks to the 8. Before the friend leaves, gives some positive, uplifting messages. The 5 says to the 8, well, you know what? I hereby pronounce you as an improved entity from now onwards. So therefore, the 1 decimal place for 0.8573 is 0.9. Okay, see for life, I think you're getting it. And I hope everybody else in the live is getting how do we round off numbers. All right. So the important thing here is identifying where do we cut off. So if it's 1 decimal place, we cut off after the first number, after the comma. If it's 2 decimal places, we cut off here. Let's say the same number, 0.8573, we were told to round off to 3 decimal places. Let's say we were told to round off 3 decimals. Okay. Yes. Linda, I like it. I think you're getting it. You're getting it. So that's why I'm saying you should always surround yourselves with 5s and more. Always surround yourself with a 5 and more. It's like the levels that you're supposed to get in your subjects. It should always be 5 and more. You don't want to be going for level 4 and less, because that's a risky level to be getting for any subject. If you are really wanting to do well, then it has to be level 5, 6, 7 and more. Does that make sense? So yes, also surround yourselves with 5s in life. Surround yourself with people that will motivate you, people that will uplift you, people that will make you better, people that will basically improve you and progress you. Okay, I love that. So hopefully it can kind of help solidify our understanding of 5 and more. Okay, so if we're rounding off to 3 decimal places, C for life has already jumped ahead. Rounding off to 3 decimal places, what do? It's after the comma, we count 1, 2, 3, we cut off at the 3rd decimal place, right? And then the 3 has a message for the 7. This number 3 is 4 and less. So what does it say to the 7? Stay the same. So the answer is 0.857. We've just rounded off this number to 3 decimal places. Guys, and it doesn't matter what decimal place, as long as we remember the message that 5 and more improves you, 4 and less basically keeps you at the same place. It does not go down, it stays the same. The number falls, the number basically gives the message, it falls away, and then it stays the same, the previous number. Okay. Do we all understand, guys? Are we all together? All right. Okay. So that's today. We are done for today. Right? So this is some homework you guys can do. I just want to give you this homework between. Okay, and people, we aren't calling this homework. We are calling this a game challenge. Okay, sorry, Dylan. Let me just do that for you. Okay. The page in the cam. All right. So this was rounding off. Okay, I mean, I can always take pictures and post them as video slides on the page itself, so I'll do that if you guys need me to. All right, so this was for the first one, rounding off the notes at the beginning, right, with the 0.725 rounding off to 2 decimal places, right? Then I'm going to move down a little bit here. This was when we basically looked at rounding off as well, but at this time round slightly different, because we are rounding off to 2 decimal places, and the number, okay, which it was basically 4 and less, which leads to the previous number staying the same. Okay, yes, Landiwe, definitely going to YouTube. I'll download it after I'm done with the session and put it up on YouTube. Okay, but then I want to just write these homework, like I said, these are not homework, these are game challenges. Remember, we want to level up, so here's a game challenge for you. Between which 2 consecutive integers does okay, you guys can do these following: the square root of 55, the cube root of 91. The fourth root of 137. Okay, so I want you guys to find between which two consecutive integers does the cube root of 50, the square root of 55, the cube root of 91, negative square root of 29, and then the fourth root of 137. You guys can do that as a game challenge. Okay, game challenge. We want to level up, guys. We want to move on to the next stage, and before we move on to the next stage of our learning, we need to obviously do this game challenge so that we can see where we're at. And then this is part A of the game challenge, and then part B. Let's round off the following to the appropriate decimal place. Let's say 1, 2, 3, 4, 78,7153, 2 decimal place, 78,7153, 3,4179, 3 decimal places, 0,99999, 1 decimal place, and then last but not least, 5, negative 5 over 32. I want you to round off that to 2 decimal places. Okay, so that is your game challenge, guys. You have game challenge A, between which two consecutive integers does these numbers lie. Okay, that's game challenge number 1. And then game challenge number 2 is to round off the following to the appropriate decimal place. So this number rounded off to 2 decimal places, this number 3 decimal places, this number 1 decimal place, and then minus 5 over 32. I want you guys to round this off to 2 decimal places. Okay, so you guys can do this obviously in your own time, but this is basically the end of our live session for grade 9 and 10. So hopefully the groups that I had asked you guys to form are actually formed, the respective groups. Please, guys, let's start those groups. I think if I remember very correctly, there's already someone who's actually Ria. Ria is the one that is responsible for grade. Let's just remind me again. And I think Ria must just comment in the comment section. So Ria is responsible for grade, is it grade 9? Ria. I don't know if Ria is still here, but if she is, it would be great if, yeah. So Ria is responsible for grade 9, and then who's my dear friend that is responsible for grade 10? Yeah, okay. Because I think at this point, grade 9 and grade 10 will start having different live sessions, okay? Because we've come to a place where grade 9 now will branch off in its own direction, and grade 10 will branch off in its own direction. This is where we start being different in our sessions. So it will be very important then that those groups that have been started, the communication lines should be open via WhatsApp, so that when there's certain lessons, I can actually send the messages to the relevant group heads, and then they can actually send the message to the others to let them know that the session will be happening this time and this Itlandoka. So I think Sia for life. Thank you so much. Thank you so much. Thank you to everyone that joined the session today. You guys do the game challenges, both of them. And then, like I said, you guys are more than welcome to send me a message on the TikTok DM and let me know so that I can then help you out and assist or check your work, how you did it, and so forth. But thank you. This is Mr. Mac. I will be posting this live lesson that I've just covered on YouTube. So the YouTube page, again, I'm just going to post up, is called Matters Again. The channel page looks like. This is how it looks like on YouTube. It's called Matters a Game. You guys are more than welcome to hop on there and check it out. And then please do subscribe. It's still got very low subscribers, as you can see. But I think we can actually get it up, and yeah, we can start utilizing it and watching the videos. And what's nice is that when you watch the video on your own, you can actually stop and pause when you want, and then take down notes when you need to. Hopefully you guys have notebooks that you are actually taking down all of these things. When you keep notes organized, and you keep the examples organized, you can always use them so that you can actually refresh your mind when you've forgotten something. That's the beauty of keeping sweet, nice notes and sweet, nice examples that have been written out neatly, so that you can actually recap on those notes whenever you forget something and you can remind yourself. But thank you so much. I hope you guys have a great day, grade 9s and grade 10s. We'll see you again. All right. When I do see you, hopefully, I think tomorrow. I know tomorrow is Sunday, so most people are going to church. But anyways, I'll be doing the session anyways at 7 a.m. Then I'll upload the session on the YouTube channel, so that if there's something that you miss, then you can actually check that out. I'll also be updating you as to which grade and what grade, is it grade 9 or grade 10, that will actually will be covering grade 9 or grade 10. I'll let you know that sort of information. And I think it was Snokotle that actually is having the WhatsApp group for the grade 10s. Ria is doing the WhatsApp group for the grade 9s. So you guys can actually escalate your numbers to those people so that you can actually be in the group and communication can actually happen. And if there's anything that you guys need to ask and all of those things, then basically I can answer those questions even outside this platform. But thank you so much, guys. I hope you guys do the homework challenge, just to show you again. That's it. Okay, please, between which two consecutive integers does those numbers lie? We need to do this as our game challenge, the first game challenge. All right, and then secondly, round off the following to the appropriate decimal place. This is the second game challenge here, 1 to 4. Okay, rounding off to the appropriate decimal place. So this is grade 9 and grade 10 together. Okay, so doing this exercise will be beneficial for both grades. Okay, Landiwe, yes, there's a group for grade 9 and grade 10 that has been started respectively by two people. Snokotle is one of the people here that's actually started a WhatsApp group. Snokotle is actually here. All right. Let me just. Yeah, that's her. Snokotle is here. So Snokotle is here. You can check. You can send her a message if you want to be added in the group there. And thank you so much, Snokotle, for the group there. Yes. Okay. Please send those numbers though to her DM. Don't post it here, because it's public information. You don't want to be, sharing your number just here. Send it to her in the DM via TikTok, and then she will actually add you to the WhatsApp group. And then at the appropriate time, I'll send Snokotle my number so that she can add me in that group, so that we can also communicate outside this platform. Any updates, any notes, or anything else that may be beneficial, or a resource that can assist you, even like pre-tests Okay, I'm hoping that after we are done with everything here in a certain section, then we can actually do. I can send a particular test in the group, in the WhatsApp group, and then I can have you guys write that test on your own, time yourself, and then after you're done, you guys can take a photo, send it to me so that I can mark it, and then we can check on your progress. Okay. Landy, okay, because we had a group which was created by someone share when we are live, even though now I told them. Oh, okay, Landy, I didn't know that. DK Mulefe, please don't share your number on the live. Don't share your number here. Don't share your number in the comment section, please. Send the number to the appropriate people. Okay. So Landy, well, maybe you can communicate with Snokuhle. I don't know, is it Landy, are you in grade 10? Is it grade 10 that you're talking about, or is it grade 9? Because like I said, today I didn't know that there was a group that had been started for grade 10 and 9. Is it grade 10, Landio? If it's grade 10, please communicate with Snokuhle so that you guys can see how to basically, which group you will officially sort of establish as the main group. Okay. But it's fine. Those people that have been added onto Snokuhle's group, that's fine. Or maybe we can have 2 grade 10 groups. All right, then Landy, what I'll do is I'll send you my number at the appropriate time, but just update me on the how many members you have in that group for grade 10. I believe grade 9 there's only 1 group though. Okay, Snokuhle is saying Landy will add me to the group. That's fine then, that's fine too. Okay, then guys, please update me the minute the group has a sizable number of people so that I can then add myself and ask someone to add me in the grade 10 group. The grade 9 group, on the other hand, is led by Uriya. So Uriya has actually started the grade 9 group. Yeah, it's just that she's not on the live at the moment. I'm sure something's up. Okay guys, thank you again. I need to leave you guys though now. Thank you so much. I hope you guys have a good day further. It is Saturday, but please be responsible. Okay, I think one of the things that's making me really sad is the news that we are seeing today. Like, there's many things that are happening. And I know grade 8s, grade 9s, grade 10s, you guys are in the midst of your adolescent stage. Please do take care of yourself. Don't do crazy things. Listen to your parents. I know your parents seem to be not popular to you in your heart and mind because there's a lot of things that you imagine in your mind you should be doing, places you should be. But honestly speaking, rather be a child and be submissive to your parents. You know, as an adult now, I look back and I'm so grateful that my parents, they were strict. You know, I didn't really like them that much in my heart when they were strict with me when I was younger. But I'm so grateful that I listened, even though sometimes I did not want to. Because looking back now, I'm so grateful that I'm not caught up in so many things that I could be caught up to as an adult. I don't drink, I don't smoke, and I'm grateful to be married to an amazing person in my life with kids. So that's something that has only come because when I was a young person, I made choices that are not popular, and probably most of them I really was like, this is not making me popular by the least. But today as an adult, I look back and I'm like, thank God I was able to avoid certain choices, because had I made those choices, maybe today I'd be talking about a different situation, maybe a baby mama somewhere else with some children somewhere else, and that would just be, I don't know, I think it would be just problematic for me. So today I can actually speak of having a wife and the fact that I have kids that are in one household, and it's not something somewhere else with some baby mama somewhere else and baby mama drama, call it what you want, and other things that could come with that. My budget, I don't have alcohol and cigarettes and other substances in my budget. So it brings a lot of peace for me for that. And God really is everything to me. So hence I can do something like this, for instance, be live. You know, maybe if I was someone else, maybe I wouldn't even be thinking of assisting, different grades on the TikTok platform for free. You know, that's just something that comes because of a heart that has been affected by God. And I'm so grateful for my young self, my younger version self, for making certain choices when I was younger, because today I'm so grateful to that young boy that wanted to do so many things in their heart of hearts, which were foolish, some of them. But I'm grateful for parents that were strict enough to actually help me navigate my boyish young self. so that today I can actually be the kind of person that I am today. And I thank God for that. So please, guys, in this festive season, to take care of yourself, don't, yeah, like I said, make those kinds of choices that your older version self will be grateful for when you look back. Okay, thank you, guys. Let me bounce out of here. And your parent, I don't know, say for life what you mean by that, but I'm so grateful for my parents. So grateful, so grateful. It's now that I'm older that I'm like, yo, my parents, they were so wise. When I was younger, I thought, oh, these guys, they're taking away from so much I could be doing. But now that I'm older, I'm like, yo, my parents were so wise. They were so wise. Well, for actually like limiting me from making certain choices. So I thank them. I really do. I do all the time. All the time. I am so grateful for them. They are amazing people, and I'm so grateful. So, yeah, make those choices, guys, that will, at the end of the day, lead to happiness. And make those choices that will, at the end of the day, not leaving you filled with so many regrets. If only I hadn't made that choice. If only I didn't do that. You don't want to be feeling like that, as an adult. Okay. Okay, guys, let me leave and love you. Thank you so much again. Maths is a game. Play it very well, and please do the game challenges that I've left with you. Do them, and then the minute you are able to finish and complete them, update me as to how it went. You can take pictures, send me on the TikTok DM, and all of that. I love you guys. Thank you. Thank you. Have a good day. Lerato Mokwame, you are so welcome. You are so welcome. Yeah, it's my joy and my pleasure to actually be doing something like this for the kids, like so much. So take care, and thank you, and continue being an amazing parent to your kids, because kids need their parents, and kids need parents that have direction. Kids need parents that can tell them, no, you can't go there, no, you can't do this, no, you won't go out at this time of the night. Kids need that. Kids will only thank their parents later. You will not be popular as a parent right now because kids want to do everything under the sun, but it helps to have boundaries, it helps to have borders, it helps to bring up kids that are disciplined. They will be the better for it in the future. They will thank you that much more in the future. But right now, you will not be popular, that's fine, but we need so much more of that in society, because you can see society is basically selling everything that's nonsensical, and everybody seems to be just lapping it up and enjoying it. And guys, we are losing it completely as a people and a nation. So we need more stability and values and morals. We need that so much so now than ever before. So let's be that, and we'll be the better for it. Our households will be better for it, and everybody else will be the better for it. Thank you so much. I feel like I'm preaching now. Let's go. I'll see you guys. Thank you again. Goodbye. Well, keep it up, Lerat. Keep it up. Keep it up. That's just a validation from a stranger. Keep it up. You're doing good. And then, of course, do show an increase of love towards your little one, so that they know at the end of the day that you're not their enemy. I think, as long as they can feel that love after all is said and done, be strict, but let them know that you love them. Tell them often enough so that they know. Thank you, guys.